Hello everyone. Um, Welcome sa isang CS31 lecture video. Ito ay isang extra na lecture video kasi meron akong mga um, na-encounter na questions na ang tinatanong bakit ganun yung formula ng Stirling numbers of the second kind. At hindi ko siya dinidiscuss sa Q&A session dahil mahaba siya. So, gawa na lang tayo ng lecture video. Okay. So, itong Stirling numbers of the second kind, recall na ginagamit natin ito kapag ang isang counting problem ay pwede mong isipin as distributing distinguishable objects to indistinguishable boxes. Ano nga uli yung Stirling numbers of the second kind? This refers to the number of ways to partition a set of m elements into n non-empty subsets. So, it is usually denoted by this symbol. Another way to denote it is using yung curly brace naman na symbol. Okay? So, ang given ay m elements at saka n non-empty subsets. So, we have to distribute the m elements into n subsets where the subsets are, again, not empty. So, note na kapag mas malaki yung n kesa sa m, yung dami ng subset kesa sa dami ng elements na i-distribute mo, edi mangyayari, meron kang mga subsets na empty, right? So, kapag mas malaki yung n kesa sa m, bali yung S of mn, yung Stirling numbers of the second kind, in that case, will be 0, right? So, para maging non-zero, the value of m should be greater than or equal to the value of n. So, ito yung mahabang formula para sa Stirling numbers of the second kind. So, bago natin i-discuss paano nakuha itong formula na to, tingnan muna natin yung sample use nitong Stirling numbers of the second kind. So, suppose we are to count the number of ways to partition 4 elements into 2 non-empty subsets. So, you can imagine meron kang isang set tapos meron siyang 4 na elements. So, one way to partition these elements to 2 non-empty subset will be ito. Bali, sa isang subset, andun si x sub 1. Tapos, dun sa natirang subset, andun na lahat ng ibang elements. Okay? So, this is another way to do it. Si x2 naman yung nahiwalay. Tapos, you can also consider yung case na may magkaka-partner. So, si x1 na i-partner kay x2, tapos si x3 at x4 sila naman yung partners. Note na ano to ha, number of ways to partition. So, ibig sabihin, pareho lang yan sa nagkabaliktad. So, nauna yung x2, x3, x4 bago yung x1. Pareho lang yan sa nauna yung x1 bago yung x2, x3, x4, right? Kasi yung nagma-matter lang sa atin ay yung partitioning and not the order. Okay? So, that's actually 7 ways. So, makocompute mo rin daw yung value na 7 by plugging in m equal to 4 and n equal to 2 sa Stirling numbers of the second kind. And then, yeah. So, let's now ask ourselves, how did we get this very long formula? I'm not sure kung si Stirling din yung nag-present ng formula na 'to. Pero ang galing. The idea is to determine how many surjective functions can we obtain from a set with m elements to a set with n elements. So para maging mas concrete, isipin natin siya with sample values. So let's say our m is equal to 5 and let's say our n is equal to 3. So you can imagine, meron tayong isang set containing 5 elements. So sabihin natin yan si set A. Tapos meron tayong set n. Set B with n elements. So meron tayong set containing 3 elements. So ang tanong, how many surjective functions can we obtain, can we form from this set to this set? Ano nga uli yung surjective function? So visually, dapat surjective ang isang function kung lahat ng elements dito kay codomain ay may nakaturo, no? So ilan 'yun? Gaano karami 'yun? In relation to the Stirling numbers of the second kind, ang bibigay kasi sa atin ng S of S given m equal to 5 and n equal to 3 will be partitioning the number of ways to partition m elements to n non-empty subsets. So, pwede natin ma-imagine na bibigyan ka niya ng number of ways to partition this into three non-empty subsets. So, for example, one way to do that ay ito. A sub 1, A sub 4 magkasama, A sub 2, A sub 5 magkasama, tapos A sub 3 magkasama. Now, kung i-relate natin siya dun sa how many surjective functions can be formed, pwede nating i-associate ang bawat isang subset sa isang element ni codomain, right? So, for example, one surjective function that we can obtain is to associate yung A1 and A4 to B1. Nakalimutan ko na mag-sub, no? B sub 1. Tama? And then, we can associate the subset containing A sub 2 and A sub 5 to, let's say, B sub 2. And then, the subset containing A sub 3 will be associated to B sub 3. Right? So, it seems makaka-generate tayo ng onto functions, surjective functions, given a partitioning. Now, notice na hindi lang ito yung surjective function na pwede nating makuha from this one, right? Another way to do it is instead of associating, let's say, B sub 2 to this subset, gawin natin na ang i-associate natin kay subset na ito ay si B sub 3. So, let's say, swap sila. Yan. So, note na, yung kulay, dinidenote niya kung kaninong element na a-associate yung subsets. So, one surjective function we can obtain is associate B sub 1 with this subset, B sub 2 with this subset, and B sub 3 with this subset. But you can also have another onto function that associates this with this subset. Tapos ito, instead of this, dito mo siya in-associate. And then, yung subset na ito ay associated sa gitnang element. Na-imagine nyo ba? Pwede rin naman na ang i-associate. Teka lang ha. Siguro isulat ko yan. So, in-associate. So para dito, in-associate natin ito kay B1, ito kay B2, B2. Hindi ko na ima-math mode para mabilis. Para sa onto function na to. Tapos kapag dito naman, so dito naman, sa naka-illustrate, bali nag-swap, no? Bali, ang in-associate natin sa subset na ito ay si B sub 3. Tapos ang in-associate natin dito sa subset na ito ay si B sub 2. So, na-imagine nyo ba? Marami pang ibang onto function na makukuha from one partition. Right? Pwedeng i-associate natin to kay B sub 2. Tapos, pwede na maka-obtain ka ng isang onto function with this naman na association ng elements to subset. Right? So, mangyayari niyan, bali, si A sub 1 at si A sub 4 nakaturo na kay B sub 2. So, ilang onto function yung pwede nating ma-associate sa isang partition? Agree ba kayo? 3 factorial? Bali, permutations nitong B sub 1, B sub 2, at B sub 3. Yan. We can generate 3 factorial surjective functions for this partition. Hindi ko na pinilapan yung iba kasi dami eh. Ang daming arrows na ituturo. Pero I think, so ito, B2, B3, B1. Ayan. So, ito yung illustration ng B2, B3, B1. So, yeah, for every partition, we can generate 3 factorial surjective functions. So, if we are to ask how many surjective functions can be formed from a set containing 5 elements to a set containing 3 elements, that will just be, in our case, that will just be 3 factorial times S of 5, 3, right? And in general, that's actually, kung M at N, that's actually N factorial times S of Mn. So, katulad ng maraming problema, pwedeng pare-pareho ng sagot, pero magkakaibang solutions, right? So, we are able to present one formula for counting the number of surjective functions from set A to set B. Now, let's present an alternative solution. So, sa solution na ito, gagawin natin, i-consider natin yung set of all functions. Let's consider the universal set. Let's consider the set of all functions as our universal set. And then, tanggalin na lang natin yung mga functions na nagva-violate ng condition for surjection. So, na-imagine nyo ba yan? Bale, una, meron tayong U to be the set of all functions, mapping A to B. And then, let A sub I be the set of all functions where yung element B sub I sa codomain ay wala sa range, not in range. So, ibig sabihin, visually, walang nakaturo doon sa element na yun. So, ang example niyan, kunwari ito yung example function natin. Itong example function na ito, bali, element siya ng A sub 1 kasi walang nakaturo na arrow kay B sub 1. Tapos, itong example na function na ito ay nandun din sa A sub n kasi walang nakaturo na arrow kay B sub n. Okay. So, paano natin mako-compute yung dami ng surjective functions? Kailangan lang natin tanggalin itong mga ganitong example functions, di ba? That is, the number of surjective functions will be the size of the universal set minus the union of all these E sub i's. Right? So note na nagsusubtract tayo from the universal set ng isang union of sets, right? Union of sets. So, pwede nating magamit dito yung generalized principle of inclusion and exclusion. So that we'll have this formula. So, note na, paano ba to? Teka, wala na siyang lalagyan. So, nagsimula yan sa ano, no? Sa, bali, may quantity muna eh. Tapos, tanggalin ko to ha. Yan. So, galing dito, gamitin natin yung generalized principle of inclusion and exclusion para makapunta tayo dito. Right? And then, bali, i-distribute lang natin yung negative sign sa labas so that we'll have this. Okay? Yan. So, andito na tayo sa formula na to. Kailangan na lang natin malaman ano yung specific values in terms of n and m nitong mga sizes na to. So let's start with asking how many possible functions are there mapping A to B. So you can imagine na one way to represent a function is to consider, let's say, yan, meron kang blanks representing M elements. Tapos, ang bawat isang element, inaalam mo kung kanino siya nakamap. Right? So, halimbawa, si A sub 1, i-map mo siya kay B sub 1. Tapos, si A sub 2 ay i-map mo kay B sub 2, and so on. Tapos, ito, this is determining kanino mo i-map si A sub n. So, pwedeng B sub 1 din. Yan. So, you have M positions, and for each position, you have N choices, right? So, that will just be N to the M, right? For each element A sub I, you have N choices to where you will map or you will assign A sub I. So, that's for the size of the universal set. So, how about this one? So, this is asking how many functions are there that does not include B sub 1. So, yun yung ano, no, what's the size of E sub 1? Tapos, how about how many functions are there na ano, not including B sub 2? Not including meaning walang nakaturo, no, kay B sub 2. So, yung size ni A sub 2 and so on. So, ilan yun? Ito raw yung formula for computing the size of the individual sets. Nag-agree ba kayo? So, ito yung question. And this is representing the size of A sub 1 plus the size of A sub 2 up until the size of A sub n. Paano natin nakuha itong formula na to? Okay, so yung n taken 1, this represents yung manner of choosing which b sub I will not be included in the function. So, choose one b sub I among the n b sub i's, right? And then, kapag nakapili ka na ng b sub I to not include, bali ito, n minus 1 to the m, represents yung assignment ng n a sub j's mo to the n minus 1 remaining b sub i's. So, yan. So, note na ano to, no? Bali, kanina na-discuss natin na na-imagine natin na pwede natin i-represent ang isang function as considering m positions, no? M each representing an A sub I. Tapos, sabi natin, kasi hindi na natin i-include si B sub I, di ba? Napili na natin kung sino yung hindi natin i-include. So, yung function natin, bali, meron ka lang n minus 1 na choices para sa lahat ng A sub j's mo. So, n minus 1 na choice para sa para kay A sub 1, tapos n minus 1 na choice para kay A sub 2 until kay A sub n, right? So that's multiplying, and through the multiplication rule, we are multiplying n minus 1 n times, right? So I hope malinaw yan. Next, ito. How many functions are there that didn't include B1 and B2 o kaya B1 and B3? So yung pairwise na ano na combinations ng 1 to n. So paano naman natin i-represent to? This will just be ano. So kamukha lang siya nito, right? Pero this time we are choosing 2 B sub i's to not include. Yan. So galing dito, we have to choose a B sub I and a B sub j among the n B sub i's to not include in the function. And once na-decide na natin sino yung B sub I at B sub j na yan, we will be representing a function as choosing among n minus 2 choices for matching the n A sub j's. So, yan. So, essentially, dito naman, halimbawa, napili natin na si b sub 1 at si b sub 2 yung hindi dapat included dun sa function, then, since hindi kasama si b sub 1 at si b sub 2, bali, yung possible assignments para kay a sub j will now be reduced to just n minus 2 choices, right? So you are multiplying n minus 2 n times, that is to represent the assignment of all the a sub j. So you can imagine, no, na ganun din to compute for this one. That will just be n taken 3 times n minus 3 to the n. I think at this point, apparent na yung pattern. So it will just be the same reasoning for all the succeeding summations. Right? So, ano ba to? Ito actually yung expanded form nito. Nitong part na ito ng formula. So, note na to represent, to include n to the m in this formula, bali, you can imagine na pwede siyang beside n taken 0. N taken 0 is just 1. So that this represents yung case na k equals 0. Okay. So, we are able to present two formulas for counting the number of surjective functions. And we can equate these two formulas, right? So that in order to get an equation for the Stirling numbers of the second kind, bali ito, ilipat lang natin sa kabila. Divide both sides by 1 over n factorial, and we'll have this. Wow.